Hello, my name's Miranda. I work with Gabby at King's College London. My background is in social sciences and bioethics, and I worked on the UKRI Net Zero Digital Research Infrastructure Scoping Project, which is a very long name, so I'm going to refer to it as the NZDRI project most of the time, from December until June this year when it completed. So, just to give you a bit of context, the rationale for the project falls under the UKRI Environmental Sustainability Strategy, which was published in 2020, and the commitment to achieve net zero across organisation-wide carbon emissions by 2040. So the ambitions of the project were to collect evidence to inform UKRI investment decisions in digital research infrastructure, to provide UKRI and the wider community with an outline roadmap for achieving carbon neutrality across the infrastructure by 2040 or sooner, and to enable UKRI to continue to play a positive leading role in the national and global transition to a sustainable economy. So, what do we mean by the digital research infrastructure? I think the prior talks have given you a sense that it's quite diffuse and diverse. And this is the UKRI definition. So it includes facilities across different scales, hardware and software, and most importantly, people, which I think has been touched on and I will come back to later on. And most importantly, all these components interact in an ecosystem and underpin research conducted across disciplines. So although this was originally the preserve of computer scientists, the digital research infrastructure is used by all subject domains within research. So this slide is just designed to illustrate that point. You've got climate science, digital humanities, mapping projects, natural language processing used for Google Translate, and modelling systems used to discover new proteins. It's used in pharmaceutical and medical research to discover druggable sites, etc. And this funding opportunity I've included demonstrates an increase in interest in the use of data-driven and data-intensive research to address medical problems and challenges. So, the environmental impact of DRI, again, I'm repeating myself or repeating others slightly, I think, but I think this illustrates the real impact of the hardware and the physical infrastructures. So, as I think Loic mentioned, that generally makes up the majority of the carbon footprint of digital research infrastructures. So that includes, for example, the extraction of minerals, transportation of raw materials, and the manufacture of hardware. The embodied carbon cost therefore falls into Scope 3 emissions. So perhaps it's helpful to think about these as Scope 3 on the left-hand side, so embodied carbon, and then the active emissions are through the energy supply, as we mentioned before. So that is the mode by which the energy used to power the infrastructures is produced. And then in addition to this, Loic touched on this, e-waste is a big issue within digital research infrastructure. So the maintenance of infrastructure followed by replacement, recycling and disposal all come into the kind of life cycle of these parts of our sort of research environment and need to be considered. So some of the challenges that our project or the project aimed to address were this equivalence between the operation of digital research infrastructure and achieving net zero. So a joint, I think the European Commission's Joint Research Committee published a report which termed the green and the digital transitions as twins. So they are mutually reinforcing, and there is a need for the use of digital infrastructure to inform progress towards mitigating the effects of climate change and achieving carbon neutrality across sectors. Subsequent to that, the expansion of data-driven research across domains. So, as I mentioned on the previous slide with all the pictures, the use of data-intensive modes of research is rising, and that's something that Charlotte demonstrated quite well, I thought, on the graphs. And this is also being driven by funders and also within kind of academic culture where there is pressure to adopt or try out new tools and demonstrate excellence through ambitious and more data-driven approaches to research. And this is relevant to the ambition for net zero because the pathway set out by the UK advisory body on climate change, the Climate Change Commission, sets out a balanced pathway which assumes that the innovation required to meet net zero will happen within stable energy consumption. So the efficiency gains are translated into energy savings rather than the rebound effect, where efficiency gains lead to increased usage. So that's a key challenge, really, because that assumption hasn't been borne out historically so far within the use of digital research infrastructure and computation more generally, so within industry. And it's estimated that the rebound effect actually diminishes economy-wide energy savings by more than 50%. So in terms of the amount of efficiency gain we need to achieve a reasonable reduction in emissions, it's much higher than the basic efficiency gained, if that makes sense. So the project took a broad approach to gathering evidence. The team began with a literature review, which is published in the interim report. I've got links to all of the publications arising from the project on the slides, which I'm sure we'll share afterwards. And the literature review informed the approach to other forms of evidence gathering activity. So sandpit projects were developed in collaboration with the wider research community, and sort of research groups were formed over 3 days of workshops and proposed questions to investigate in order to address the challenge of net zero. And then consortium projects were ideas initiated by the core team responding to gaps in the literature, and they generally focused on case studies of UKRI facilities. So they include JADE, Archer 2, which is a supercomputer, Jasmine, which is a large-scale data centre near Didcot at the Harwell campus, and Scaffold Pike. And they also included other kind of forms of engagement, so through the Artist Commission and with the wider research community across subject domains through the DRI User Behaviour Survey. And then they also held stakeholder engagement events with early career researchers, established researchers, and covering subjects including procurement, training, and values and responsibility around DRI use. So I don't have time to go through all of the recommendations, but what I've tried to do is pull out a snapshot of the requirements that the project kind of produced that would kind of map towards net zero. So first, I think it's been mentioned a few times, standards for DRI interfaces and monitoring and reporting combinations is useful both at facilities level in terms of comparability of, I guess, efforts made to reduce emissions associated with their activity, and also for individual researchers, so for you to understand the impact of your work and how you can, I guess, monitor your own improvements. Additionally, facility design and procurement need to be permissive for energy use monitoring. So a couple of the sandpit projects explored the impact of heterogeneous infrastructures on carbon emissions and energy draw, and they highlighted two things. One, that differential combinations of like hardware components had an impact on energy use, and also that idle power draw contributed a relatively high proportion of emissions associated with that facility. So steps taken through design at the initiation stage to reduce idle power draw was important. Also in the procurement of additional components to further reduce idle power draw in existing facilities needed to consider the embodied carbon emissions associated with that investment. Second, I thought this was an interesting discussion that kind of happened at the end of the first half around job scheduling. So whether you schedule at an individual level, your algorithms for lower carbon intensities, so when the grid is being supplied with a higher proportion of green energy, or you, at the facility level, aim to operate at capacity, which ensures that you have a more efficient use of your embodied carbon cost of the facility as a whole. So some of the projects suggested that owing to the high idle power draw, it made more sense to run the facility at capacity given that there was an energy expenditure when it was idle. But I think this speaks to a broader issue around demand. So what is the demand and therefore capacity, like reflexive capacity action, and how that's managed, and that kind of comes on to my next slide a little bit. And in terms of investment, I I think there are available tools, which I think we'll hear some more about as well, but continuing to invest in sustainable research processes and evaluate them relative to one another in terms of like accuracy, reproducibility. This is an important thing that as a funder UKRI needs to consider, and also to invest in carbon accounting tools such as the ones we've heard of. Second, one of the main areas which I think is relevant to the room at large is training and skills development. So one of the things that's very important around raising awareness and facilitating kind of positive action on the carbon intensity of digital research is an understanding of environmental impacts of research practice. And that includes, I think, thinking about the appropriateness of technical approaches to problem solving and data efficiency. So how large does a data set or model need to be to adequately address the question? And these are kind of information that needs to be delivered across the hierarchy of the research ecosystem. So both from strategic priority, people setting strategic priorities, those running facilities and researchers. Second, best practice for the use of DRI includes software design and code optimization, the effect of software-hardware combinations on emissions, and low-carbon data management protocols. And also the availability of skilled software engineers to support a non-expert audience. So I would count myself as a social scientist researcher as being a non-expert in digital approaches to research in terms of improving the kind of sustainability of my work. So that was something that came up quite a few times. And lastly, in order to make all of those changes practicable and easy, it's really important to formalise incentives to pursue sustainable research practice. And I thought this quote really succinctly summarises that researchers operate in what can be a very rigid system that incentivises existing ways of working for pursuit of, and I think, Charlotte, you touched on this, career trajectories and progression. So funders and other institutions, universities, publishers, journals, need also to share in the same intention and objectives in terms of approaching research sustainably. So funders should embed environmental impact estimates and monitoring in their application criteria. They also need to provide funding for more sustainable approaches to research, including green software engineers or research software engineers on projects, which I think is an existing issue anyway. And open science and fair data principles should be required of researchers using UKRI DRI facilities. And again, as a leader, by setting that requirement, there's a case for all other funders following suit. And DRI facilities should contribute to a public energy register through annual monitoring. So that also contributes to raising awareness and visibility amongst the research community, and also, I think, accountability. So those were the kind of a snapshot of some of the requirements highlighted by the project. The take-home messages are that UKRI is committed to environmentally sustainable policy. The DRI does have environmental impacts, so although it plays a role in addressing the society-wide net zero challenge, the implications of expanded usage should not and cannot be overlooked. The UKRI operates a leadership role, and I think this is most important, that small incremental changes support awareness raising as well as emissions reductions, and are fundamental to leveraging design and intent. So the rationale for integrating services, for example, meets multiple objectives, but if sustainability is not included there, then I think that outcome is less likely to stick, and the intention to address the rebound effect in particular is key. So here are all the publications, and that's it from me. Thank you so much for listening.